For this video and for the remaining lessons in the unit, we're going to talk about matrices. So this is going to be a basic introduction to matrices, and then next video and the video after, we're going to talk about how we can use matrices to solve systems of equations. So this is just going to be a basic introduction on what we're going to go through, what a matrix is, and some basic operations with matrices. So to start, a matrix is an array of numbers arranged in rows and columns. So for example, if I have like 3, 2, 1, 4, 5, 6. So this is a matrix right here. We put little brackets on the outside. And the way we kind of notate it is there are 2 rows for this example and 3 columns. So this is a 2 by 3 matrix because there are 2 rows and 3 columns. So the row comes first and then the column comes next. All right, so we're going to start the video with the basic operations with matrices. And then, like I said before, you'll see how this applies to systems of equations in the next video and the video after. All right, so if we're adding matrices, let's start with addition. The matrices have to be the same size. In other words, the rows and the columns have to be the same for addition to work. Otherwise, you can't perform the addition. So let's add the 2 matrices together. So we have the matrix 1, 2, 3, 4 plus the matrix 5, 6, 7, 8. And the way it works is we take each element in the matrix and we add the same element in whatever matrix we're adding to the original. So, for example, for this first one, we're just going to add 1 and 5, and so we get 6 right here. And then similarly, we're going to add 2 and 6, and so right here we get 8. For the next one, let's use orange, we're going to add 3 and 7, so this is 10 down here. And then lastly, this is 4 and 8, and so we're going to add those 2 together and get 12. And so that's matrix addition. Pretty straightforward, I think. So it's simple addition, but you have to just add the number in the same location for each matrix. Okay, subtraction. So let's do the same thing. Let's do the following. So let's do 6, 8, 10, and 12. And let's subtract 5, 6, 7, and 8. Okay. It's going to be the same exact thing, except instead of addition, it's subtraction now. So we have 6 minus 5. Oops. 6 minus 5. That's 1. Next we have 8 minus 6. That's 2. Then we have 10 minus 7. Well, that's going to be 3. And then lastly is 12 minus 8, and that's 4. And so notice here that this is essentially the same equation as we had written above. It's just rearranged differently. What happens if we multiply by a constant? So multiplication by a constant. A constant just means it's a number. We're multiplying a matrix by a number. So let's say we have a 3 by 2 matrix. Let's say 2, 1, 3, 4, 8, 1. And let's multiply by the number 4. Well, all we're going to do here is we're going to take each element in the matrix and we're going to multiply that number by 4. So the new matrix is going to be 8, 4, 12, 16, 8 times 4 is 32. 1 times 4 is 4. And so that is the resulting matrix when we take this 3 by 2 matrix and multiply by the number 4. Where this gets a little complicated is when we are dealing with multiplication. So general multiplication. I'll say multiplying matrices. Okay, so let's say we have the following two matrices. 1, 3, 5, 2, 4, and 6. And we're going to multiply this matrix by the matrix 3, 2, 1, 4, 2, 5. So there's two things that make this tricky. Before we go through those two things, let's just write the dimensions of each of these matrix. So the first one has 3 rows and 2 columns, so it's 3 by 2. And the second one has 2 rows and 3 columns, so this is 2 by 3. Okay. The first thing you want to notice is that sometimes you are allowed to multiply matrices together and sometimes you are not. In this case, you are allowed to multiply them together. And the reason behind that is because these numbers right here are the same. These are the same value. These must be the same, these two numbers on the inside. If they are not the same, you would say the result is undefined. So you're not allowed to multiply two matrices whose dimensions give you different numbers here in the inside. The resulting matrix is going to have the dimensions of these two numbers. This is the size of the final matrix. Okay, so the weird thing about this example is it's not quite as easy as addition and subtraction because the actual dimensions of the matrix are changing as well. Okay, so before we actually go through this one as an example, I'm going to come back to this one and we're going to go through an easier one and then come back to this one. But these are the situations where where multiplying matrices work and where multiplying matrices does not work. So the numbers in the inside have to be the same for it to work. The resulting matrix is going to be the numbers on the outside. So because the number on the inside is a 2, so it's 2 by 2. It's not 2 by 2, but the two numbers are 2. The resulting matrix is going to be 3 by 3. Let's try an easier example, and then we're going to come back to that one. So let's say we have the two matrices being multiplied together. So 1, 2, 3, 4 multiplied by, I'll write a dot here instead of a times. 5, 6, 7, 8. Okay, pretty straightforward. Let's determine first if we're allowed to multiply these together. This is a 2 by 2, and this is a 2 by 2. We'll notice here the numbers on the inside are the same, so we are allowed to undergo this multiplication, and then the resulting matrix is going to be these numbers here on the outside. So our answer will be a 2 by 2 matrix. But what is the answer going to be? All right, it gets a little tricky. So the way we do this is we multiply the rows by the columns. Okay? So for the first example here, we're going to multiply the entire first row. We're figuring out what number goes here. Okay? We're going to multiply the first row with the first column. Okay? And so the way it works is we're going to do 1 times 5 plus 2 times 7. So that's the first element in this new matrix. Okay, the second one. Let's just go down. It's going to be this row by this column. So we do 3 times 5 plus 4 times 7. Okay. Next one. So notice the rows and the columns align. This is the first row right here. And this is the second row. Let's try the top right. So for the top right, we're going to do the first row by the second column. So first row by the second column. This is going to be 1 times 6 plus 2 times 8. Okay, and the last one is going to be the second row and the second column. And so this will be 3 times 6 plus 4 times 8. Okay, and then the resulting matrix from this multiplication is going to be what we get when we evaluate each of these elements. And so 1 times 5 plus 2 times 7, that's 5 plus 14, that's 15. 6 plus 16, that's 22. 3 times 5 plus 4 times 7, that's 15 plus 28, that's 43. And then lastly, 3 times 6 plus 4 times 8, that gives us 18 plus 32, 50. Okay, and this is the result from multiplying these together. Okay. All right, to wrap up the notes for today, let's go through a more challenging matrix multiplication. So the resulting matrix is going to be a 3 by 3 matrix. This one's going to be a little bit more complicated. Okay, so we're going to start by multiplying the first row here by the first column. So 1 times 2, or 1 and 2 and 3 and 4. So 1 times 3 plus 2 times 4. Okay, next. Let's do the second row and the first column. So if we're in the second, this is the second row in the first column right here. So that is going to be 3 times 4. Sorry, 3 times 3. I'm reading that wrong. 3 times 3 plus 4 times 4. Okay, and then the last one here is going to be the third row and the first column. And so that will be 3, or I'll write it like this, 5 times 3 plus 6 times 4. Okay? So now we're going to do the next one. So this one is going to be, this is the second, or it's the first row, but it's the second column. So we're going to do first row, second column. So 1 times 2 plus 2 times 2. Next. I'll try and go through these relatively quickly. It is a little tricky though. Next is going to be this is the second row in the second column. So second row, second column. So 3 times 2 plus 4 times 2. Next is going to be the third row and the second column. So 5 times 2 plus 6 times 2. Okay, and we're just left with the last column. So it's going to be 1 times 2, are 1 and 2 and 1 and 5. So 1 times 1 plus 2 times 5. Three and 4 and 1 and 5, so 3 times 1 plus 4 times 5. Okay, and then lastly, 5 times 1 plus 6 times 5. Okay, if you're ever stuck about how to do this, just think, what row am I in and what column am I in? So, for example, this last one is the second row and the third column. So you're doing the second row times the third column. Okay, but it is tricky. The best way to get good at these, I think, is just to practice, but let's evaluate what this result is. It's going to be a 3 by 3 matrix. Okay, so the result here is going to be what we get when we multiply all these together. Okay, and you'll get to a point when you're going through these, once you go through enough and you get a handle on how the arithmetic kind of works, where you can kind of skip this part and you just go straight to the value. So what we get here is 8 plus 3 is 11. This is 25. This is 39. 6, 14, 22. And this is 11, 23, and then lastly 35. Okay, and that's the resulting matrix when you multiply this 3 by 2 by a 2 by 3 matrix. Okay, so this is a little tricky. It can be kind of confusing. I think the addition and the subtraction should be pretty straightforward, but the multiplication is definitely going to be a challenge when you're going through these. So let's go through an example and a practice problem as well. Okay, so let's start by evaluating these three expressions using those properties that we just went through before. So number one is we're just going to multiply. We're going to treat A and C as a constant, so we're going to multiply this matrix by 4C. And so all we're going to do here is multiply each individual element in the matrix by 4C. So the resulting matrix here, again, C is going to be a number. So this becomes, what's 0 times 4C? Well, that's just 0. 6 times 4C, that's 24 times C. 0 times 4C again is 0. And then lastly, 3A times 4C. That's 12AC. And that's the answer for that one. Okay, not too bad, I don't think. Next one also isn't too bad. We're going to add these matrices together. It's a 1 by 3 matrix because there's 1 row and 3 columns. They have the same, these two matrices have the same dimensions, so we're allowed to multiply them or add them together. That's all we're going to do is add each element that is in their respective locations. So 1 plus 2 is 3. Negative 5 minus 2, that's negative 7. And then lastly, negative 3 minus another 3. That's going to be negative 6. Okay, this is where it gets a little tricky again. Now let's try this matrix multiplication. And I really encourage you guys to try this on your own before going through this, kind of the key on the video. So this is remember, it's always rows and then columns. This is a 3-row by 2-column matrix, and this is a 2-row by 2-column matrix. So first, think to yourself, are we allowed to multiply these together? Do these numbers match up? Yes, they do. The resulting matrix is going to be a 3 by 2 matrix. Okay, so it's going to look like it's going to look like this matrix right here. Okay, so how do we do this again? Let's start with the first row in the first column. So we're going to multiply this row, so it's a little confusing, this row by this column. So we get 5 times 3 plus 2 times negative 2. Okay, next, let's take this and multiply it by the second row. 0 times negative 4 plus, sorry, it's really easy to make small mistakes here. 0 times 3 plus negative 4 times negative 2. Next one is going to be the third row and the first column. That's 1 times 3 plus 6 times negative 2. Okay, now we're going to do the same exact thing we did before, except instead of using the first column for the second matrix, we're using the second column for the second matrix. Okay, first row, second column. 5 times 7 plus 2 times 0 plus 2 times 0. Next, it's going to be the second row in the second column. That's 0 times 7 plus negative 4 times 0. That's just going to be 0, but I just want to show out these steps because we're still just getting started with this. And then the third row in the second column is going to be 1 times 7. So 1 times 7 plus 6 times 0. Okay, let's evaluate this. So we end up with 15 minus 4, that's 11. This becomes, well, the first term is 0, and then it becomes positive 8. 3, this is 3, and then minus 12, so it's negative 9. Okay, that's the first column of our resulting matrix. And this will be 35. This is just 0. And the last term is 7 plus 0, which is 7. So that's the answer for this one. Okay. And let's wrap up this video by going through just one more question involving multiplying matrices. And then I do want you to spend a lot of time in class practicing this stuff. Okay, let's say we have two operations going on here at once. One is multiplication and one is addition. Similar with normal operations, we're still going to abide by this rule right here, where the multiplication operation will come before the addition operation. So before we add these matrices together, let's evaluate what this is by undergoing multiplication with these matrices. So this is a 2 by 2 matrix. This is a 2 by 2 matrix. Well, these are the same. And we're going to get a 2 by 2 matrix as a result, which means that we can add it to this. And so we will have an answer here. We won't get an undefined value. Sometimes I will try to trick you guys, and I'll give you an expression that you can't actually evaluate, just so you understand how the dimensions work when you're performing this arithmetic. So when you're doing addition, the matrices have to have the same exact dimensions. With multiplication, not always, it's a little bit different, okay? So how do we do this? Let's evaluate this matrix multiplication here first. And so let's go through each of these. So I'll just do it, I'm going to do this down here. So we get, well, yeah, I'll do this one more time. First row, first column. Negative 5 times 3 plus negative 1 times 1. First row. First row, sorry, I'm trying to get the colors right. First row. And then second column. That's going to be over here. So we get 5 or negative 5 times 6 plus negative 1 times 6. Okay? Second row, first column. So this is negative 4 times 3 plus 2 times 1. Okay, and then lastly, it's going to be second row, second column. So think to yourself, what am I looking for right here? How do I get this number? Well, I want to do the second row, because we're in the second row of the first matrix, and multiply by the second column. Okay, so we get negative 4 times 6 plus 2 times 6. Okay, now the result here is going to be what we get when we perform this arithmetic. But this won't be our final answer because there's one more thing we need to do after. So what we get here is negative 16. So negative 16. This down here is negative 10, negative 36, negative 12. Okay, and let's bring this up here. So the answer is going to be what we get when we take the original matrix here, which we didn't do anything to yet, but we're going to add to this our result down here. Okay, and this is the easy part. Multiplication is the hard part. So now we're just going to add each number in each respective element. So negative 1 plus negative 16, well, that's negative 17. Negative 1 minus 36, that's negative 37. Negative 6 minus 10, that's negative 16. And then lastly, 3 minus 12, that's going to be negative 9. Okay, and that's going to be the answer. This is the answer right here. Okay, I won't go through the next problem set because I do want you guys to try these on your own. The answer key for all these problem sets will be on the one if you scroll down, but I want you guys to work through problem set number 1, then problem set number 2, and then if you'd like, there's a challenge question in the OneNote as well. It's really important that you guys understand how to use these operations to evaluate matrix expressions, because this is going to come into play when we start applying this to systems of equations.